Okay, a certain bacteria doubles every 20 minutes, and doubles is important. We'll look at that word again in a minute. Beginning with 10 cells in the culture, the population can be represented by the function B equals 10 times 2 raised to the T. B is the number of bacteria cells, and T is the time in 20-minute increments. So we don't need a specific equation for this one, and if you see down here, these the problems below specifically say exponential growth and decay. That one's, so down there, that's your opportunity to use one of those formulas. But this one, you already have a formula given. Let me pull up my pencil real fast. You already have a formula that says B is equal to 10 times 2 raised to the T. So you already have that formula. Let me make my pen smaller here. Okay. And so all you need to do is be able to fill in T for time. And right here it says T is the time in 20-minute increments. So I know that there are 3 20-minute increments in every hour. So that says how many will there be after 2 hours? Some of you might want to plug in a 2 for T, but don't do that because that would be wrong, because it doubles every 20 minutes, so therefore it's going to be able to double 6 times. So if you just put in your calculator 10 times 2 raised to the 6, it will give you a final answer of 640. Okay, again, notice that this section of the study guide is called Exponential Growth and Decay. So therefore, you're going to need to know one of the two formulas, and you'll have to know whether it is something that is increasing and then you have growth, or is it something that is decreasing or depreciating and then you have decay. So let's read this situation and determine which of the two formulas we need to use. A college tuition has risen. That's a word right there. I think we got growth already. All right, and we have a rate of 5% each year since 2000. If the tuition in 2000 was $10,850, write an equation for the amount of tuition in 2 years after 2000, and then predict the cost of the tuition for 2015. All right, first of all, we need to know what the growth formula is. Okay, so I've listed the formula. Whoa, that is not the formula. That's moving. I need my pencil. There we go. Okay, so I've listed the formula here. All we need to do is fill in. So let's start writing the formula. All right, so first the P is our principal amount, and it said that the tuition in 2000 was $10,850. So that's our starting amount. And you always put a parentheses, and then you'll put a 1 here always, no matter if you're doing growth or decay. And the only difference between your growth and decay formulas is the sign right here. So we know we're going to use growth, so we're going to use a plus sign. And then the R stands for rate. So we have a rate of 5%. So what that looks like is that right there. So we're going to move the decimal 2 places to the left. So that's 1 and 2. So our rate is really decimal 0.5. And we are raising it to the T in time. The question also asks us to predict the cost of tuition for this college in 2015. So we need to fill in the piece of information that we don't have, which was T, the time. So if we started in the year 2000 and it wants to know a prediction for 2015, then we know that's a difference of 15 years. So you're going to use this exact same formula. And you're going to get a final answer of $22,556.37. All right, number 10 is still in the growth and decay formula section, so we're going to determine which one to use. The population of Rowan County has been decreasing. That is not a highlighter. And we can still read that. Has been decreasing at an average rate. So decreasing right there tells us that we're going to be using our decay formula. And it decreases at an average rate of 0.3 per year %. So it starts in 2002. Its population was 88,647. So first we're going to write an equation to represent the population since 2000, and then we're going to predict the population in 2015. So first of all, let's remember our decay formula. All right, pop the decay formula on there for you. And as you can see, it's exactly like the growth formula, except there's a minus sign. So let's get this started. Get my pen. Okay. All right, so the first thing it's going to ask is for an initial amount, and it said that it started an initial amount of 88,647. Remember, that's always going to be a 1, and this is going to be a minus because we're dealing with decay, and it wants to know the rate. So if we have a rate of 0.3, when we move the decimal 2 places to the left, it's going to give us an answer. Pen's not working very well right there. 0.003 is our rate, and raised to the t power. And now let's, if the trend continues to predict the population in 2015. So what we're going to do is replace this t with a 15. And we picked 15 because we started at year 2000, and it wants to know the population in 2015. So I subtracted the 2, giving me a difference of 15 years. And when you type all of that into your calculator, you get 84,740, and we can just round that to 58. And that was the population in 2015. Okay, for number 11, we're going to read the problem first, and then we're going to make a decision on whether we think it is a growth, decay, or it might be something else that we learned about. If you invest $300 into an account that earns 3.5% interest compounded monthly. Here's our key word here. Anytime you see the word compounded, you know that you're going to use your compound interest formula. And I wants to know how much this was, if it was compounded monthly after 8 years. So first of all, we should probably be familiar with the compound interest formula. All right, throw that up on the screen for you. You can see P is the principal, or basically where you started with. So we started with $300. Let me get my pencil. All right, so our compound interest started with $300. Oh, that doesn't go there. There we go. There's always a 1. There's always a rate. So if we had 3.5%, we're going to move the decimal 2 places to the left. It's really decimal 0.035%. And we're going to divide it by the number of times that it was compounded that year. So I see that it was compounded monthly, therefore I know that that happens 12 times a year. So that is my N, number of times that it's compounded. And I'm going to multiply it times the number of years, and in this case it's 8. And I'm also going to multiply that times the number of times that it was compounded. So I'm also going to do 8 times 12. So it's all raised to the 8 times 12. Plug all that into your calculator, and you will get a final answer of $396.78, and that's how much money you should have in your account after your interest has been compounded. Okay, let's read this problem to decide which formula we should use. In 2010, Sylvester makes an investment of $4,500 in silly bands. It has been losing money at a rate of 5% annually. How much will his investment be worth in 2015? So only one of the formulas had a minus sign, and that was the decay formula. And also you'll notice this problem has nothing about compounded interest at all. So we are going to use the exponential decay formula. Okay, so we're going to fill in for what we know. I've thrown the exponential decay formula right there for you. So we always know that we're going to start with our principal or starting amount, so that's $4,500. And we always have a 1, and since this one's decay, we have a minus. And then we always put our rate in. If we have a rate of 5%, we're going to move our decimal 2 places to the left, giving us a rate of 0.05. And we're going to raise it to the t. And if we started in the year 2010, and it wants to know how much an investment will be worth in 2015, that's a difference of 5 years. So you're going to raise it to the 5. And when you plug all that into your calculator, he now has $3,482, and looks like we'll round that to 1 cent. And that's how much he has after losing money in silly bands. So the moral of the story is do not invest in silly bands, guys.